Hello students, finding the square root of a number is one of the most important operation in the practical applications. Also, finding the square root of higher digit number is a very difficult task. In this lesson, we discuss different methods and their limitations and some simple tricks to find the square root of higher number very easily. We all know that the inverse operations for addition and multiplication are subtraction and division respectively. In the earlier lesson, we learned how to find the square of 2 and 3 digit numbers with some simple tricks. Now in this lesson, we will see its inverse operation called the square root operation. Let me ask you some questions. If the area of a square is 64 square units, then what could be the side of the square? In a right angle triangle, the length of the hypotenuse and a side are respectively 12 units and 5 units. Can you find the third side? In all these cases, we need to find a number whose square is known. Such number is called the square root of that number. In this lesson, we shall take up only the positive square root of a natural number. The positive root of a natural number, say n, is denoted by square root of n as shown. There are several methods to find the square root of a given number. Let us see some methods and also their limitations. First method. It is through repeated subtraction. We know that the sum of the first n odd natural numbers is n square. That is, every square number can be expressed as a sum of successive odd numbers starting from 1. Let us take an example by using this technique. What is the square root of 25? Let us observe the following subtractions. 25 minus 1 is equal to 24. 24 minus 3 is equal to 21. 21 minus 5 is equal to 16. 16 minus 7 is equal to 9. And 9 minus 9 is equal to 0. Hence, from 25, we subtracted successively odd numbers starting from 1 and obtained 0 at the fifth step. Therefore, square root of 25 is equal to 5. Like that, by identifying those subtractions and the number of odd natural numbers using in that subtraction, we can find the square root of such numbers. But when the number is very big, then this method is very time consuming. Okay, let us observe second method. It is through prime factorization. Let us observe the following table which gives the prime factorization of some numbers in the first column and the prime factorization of their squares in the second column. Let us observe. In the first column, the first number is 6, which is equal to 2 into 3. In the second column, its square 36, which is equal to 2 into 2 into 3 into 3. Next number is 15, that is equal to 3 into 5. Then in the second column, its square 225, that is equal to 3 into 3 into 5 into 5. Next number is 18, which is equal to 2 into 3 into 3. In the second column, its square is 324, which is equal to 2 into 2 into 3 into 3 into 3 into 3. Thus, we can observe that the prime factorization of a square number contains twice the number of factors of that number. Let us use this to find the square root of given number. For example, what is the square root of 225? By pairing the prime factors of this number, we get 225 is equal to 3 into 3 into 5 into 5. That is equal to 3 square into 5 square. That is equal to 3 into 5 whole square. Therefore, 225 is equal to 3 into 5 whole square, and hence square root of 225 is equal to 3 into 5, that is equal to 15. Hence, the square root of 225 is 15. Like that, by observing their prime factors, we can find by grouping them and its root also. But again, this method also has a limitation, that when the number is big, then finding its prime factors and pairing them is very lengthy. So let us observe the next method, that is third method, which we call it as division method. In fact, when the numbers are big, then this method is useful. Before that, let us observe the following point. If a perfect square number is a 3-digit or a 4-digit number, then its square root will have 2 digits. In general, if a perfect square number is of n digit, then its square root will have n by 2 number of digits if n is even, or n plus 1 by 2 number of digits if n is odd. By using this fact, we will see the division method by taking an example. Let us find the square root of 729. First, we can estimate that the square root of 729 has 2 digits. Now, to find its square root, we will have the following steps. Step 1. Place a bar over every pair of digits starting from the unit digit. Step 2. For the digit with single bar, let us find two numbers such that the given digit lies between the squares of these two numbers. In this case, 7 lies between 2 square, that is 4, and 3 square, that is 9. Step 3. Using 2 as a divisor, let us divide the digit 7 and got the remainder 3. Step 4. Double the divisor and enter it with the blank on its right. Here it is 4. Step 5. Guess a largest possible digit to fill the blank, which will also become the new digit in the quotient, such that when the new divisor is multiplied to the new quotient, the product is less than or equal to the dividend. In this case, 47 into 7 is equal to 329. Now, since the remainder is 0 and also no digits are left in the given number, we conclude that the square root of 729 is equal to 27. In fact, by slight modification of division method and using little guesswork and common sense, we can find the square root of higher digit numbers very easily. For this, we need to know the squares of 1 to 10, which you know already. Okay, let us list these squares as follows. 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25, 6 square is equal to 36, 7 square is equal to 49, 8 square is equal to 64, 9 square is equal to 81, 10 square is equal to 100. Now let us try to find the square root of some numbers by using this simple trick. Let us take what is the square root of 841. To find the square root, we have the following steps. Step 1. Divide the number into two parts by taking unit and tenth digit together as one part and the remaining digits as other part. Let us identify these two parts by putting bars below them. Step 2. Find two numbers such that the last digit, here it is 8, lies between their squares. In this case, it is 2 and 3 such that 2 square, that is 4, less than 8, which is less than 3 square, that is 9. Step 3. Identify the lesser number as the leftmost digit, that is 10th digit of the required answer. Here it is 2. Step 4. For the unit digit, let us observe the unit digit of the given number. Here it is 1. Now from the list of squares, we see that 1 comes as a first digit at 1 square and 9 square, that is at 1 and 81. Hence, from this observation, we conclude that the required unit digit in the final answer is either 1 or 9. Hence, the answer is either 21 or 29. Step 5. To choose the right answer between them, let us use the two numbers we identified in the first step. Here it is 2 and 3. Add 0 and make them as two-digit numbers like 20 and 30. Take their squares, that is 20 square, which is equal to 400, and 30 square, which is equal to 900. Step 6. Now we observe that the given number is near to which of the above two numbers. In this case, 841 is nearer to 900. This concludes that the required unit digit in the answer must be 9 only. Hence, the answer is 29. Therefore, the square root of 841 is equal to 29. Let us take another example which contains 4 digits, say 2304, and observe all the steps. Step 1. Divide the digits 2, 3 as one group, 0, 4 as another group. Step 2. Identify 4 and 5 such that 4 square is less than 23, which is less than 5 square. Step 3. Since 4 square is less than 23, the answer is 4 as a 10th digit in the required number. Step 4. From the table of the squares, the unit digit 4 appears at 2 square and 8 square. So the answer is either 42 or 48. Step 5. 40 square is equal to 1600 and 50 square is equal to 2500, such that 1600 is less than 2304, which is less than 2500. Step 6. Since 2304 is less than 2500 and is near to 2500, hence the square root of 2304 is equal to 48. Do you find very interesting? Okay, let us take one more example, say 13,225. Observe that it contains 5 digits. And let us see how the steps follows in this case. Step 1. Take two groups from the digits of the given number such that one group contains 132, another group contains 25. Step 2. Choose 11 and 12 such that 11 square is less than 132, which is less than 12 square. Step 3. Since 11 square is less than 132, this gives the 100th and 10th digit in the given answer as 1, 1. Step 4. Here the unit digit is 5 and 5 appears in the list of squares at 5 square only. Hence, the unit digit in the required answer must be 5. Hence, the square root of 13,225 is equal to 115. So like that, by identifying the properties of digits and using the tables of the square, we can find the answers very easily. Let us recall what we learned in today's class. Today we understand subtraction method, prime factorization method and division method to find the square root of a given number and also their limitations. That is, we observe that the first two methods are time consuming when the numbers are big. Finally, we find one simple trick which helps us to find the square root of higher digit perfect square number very easily. In fact, we apply this trick to the examples of 3-digit, 4-digit and 5-digit numbers, and we saw that answers are very easily obtained. I hope this will help. Thank you and have a nice day.